Right, so we're downloading this Starwood XLSM. I'm going to go ahead and open up this file. And so our topic for today is it's learning about a thing in VBA, and it's a general idea in very many programming languages called an array. Now, I know some of you have some programming experience, so if you would just show me by a raise of hands, how many of you already know how to use arrays? Or how many can already use arrays? Okay, about half. I know I can. Every time I get a paycheck, I look at it and say, boy, I sure can use arrays. Yeah, there's not that many jokes here in this class, folks. We got to take what we can get. So, so the idea here then of an array. So the problem with the way that arrays are typically taught is that we teach it, and I think our book kind of falls into the same category, that it's taught as if an array is a new idea. It's something completely new, and it's not. It's something really similar to what we've worked on already. In fact, let's just kind of go over the English language. Remember, array isn't a word it's a word in the English language. I could stand over here in the corner of the room, and I could look out, and I could say, my, what a beautiful array I see. Does that make any sense? I mean, have I really expressed a full thought here? In English? Like, you guys don't know? You have an opinion. Is it a complete thought? My, what a beautiful array I see. Yeah, you want to know what? You want to say it louder. An array of what? Yeah, it doesn't make any sense to talk about an array unless it's an array of something. Because an array by itself, you haven't said enough. And that's really true in the world of programming too. When we're talking about an array, we're talking about an array of something. In fact, you've got your computers open, so someone look for me the definition of just look it up. Google the definition of an array. You know, there's several of them out there, and I want to find one in particular that we might rely on for today's discussion. So yeah, go ahead. What does it say? So an impressive collection of a particular type of thing. Yeah. So it's always of a particular type of thing. So I could say I have an array. There's an array of students, an array of chairs, an array of desks. There's an array of these strange rectangles on the wall. There's an array of those. There's an array of lights here. But it's always an array of something. And in VBA, it's an array of something. Can you guess what it is? An array of, we're going to be learning about an array of, objects is always a popular choice, but it's not an array of objects. Any other guesses? So that's something we have learned about. We spent quite a bit of time. You're familiar with this construct. An array of variables. Yeah, that's what it is. It's an array of variables. And so, and we always talk about it just as being an array because the array of variables is just always implied, but it seems like you should know that's what we're talking about. It's an array of something. So I'm gonna tell you a story that happened when I was like 12. Well, kind of starts when I was 12 and ends when I'm 14 or so. And I'm telling you this story mostly for myself, to remember that when we first get introduced to the idea of an array in programming, that it could be somewhat difficult. So in 1979, during the summer of 1979, I was staying at my Uncle Jim's house in Salt Lake City. So I was raised in San Diego, but during the summer, we'd go stay different places. And so my whole family is, for a couple of weeks, visiting Uncle Jim. He's got a huge house in the avenues in Salt Lake. And it's like 5 o'clock in the morning, and my father comes into the room. I'm sleeping in the basement. And he says, son, the house is on fire, and the fire department has asked us to evacuate the building. And my father was not a jokester at all. And there was no doubt in my mind that what he had just told me was true. And so I kind of groggily, put some shoes on and headed outside. Sure enough, there's fire trucks, they're spraying water on the house, there's smoke coming out, house on fire. So my father was general contractor, and so Uncle Jim hired my dad to remediate the fire damage at his house. And as part of the payment, he taught my dad how to program. Uncle Jim was a brilliant programmer. He ran a company in Silicon Valley, and it actually had to do with estimating the price of print jobs. So you have something printed, you need software that estimates that. That was what his company did. After my dad's done fixing the house, Uncle Jim hired him, and he went to work in San Jose. So he would fly up from San Diego to San Jose Monday morning, and he'd fly home Friday afternoon, and he was kind of an absent dad for about a couple of years. Then Uncle Jim's company got bought, and my dad was all, you know what, we've had enough of this. And the truth is, he was never really a very good programmer. He was okay. He's a better builder than he was a programmer. So by now, I'm like 14 years old, and My dad thinks, all right, son, been programming for a while. I'm gonna, teach you. We're gonna have a talk. 14 years old, time to have a talk. I got to teach you about arrays and programming. Great, Dad. I'm ready to learn about arrays. And so I said he wasn't a very good programmer. He was okay, but he wasn't a very good teacher. And in this instance, the combination of the two was just really painful. And so he starts off by talking about, Dad, if you're listening, I love you, whatever. So he starts talking about pigeonholes, using a metaphor to help me understand what an array is. And the truth is, I had no idea what a pigeonhole was. And I didn't know enough about teaching at the time to say, Dad, if you're going to pick a metaphor, you should pick one that the learner is familiar with. The whole idea is to kind of connect with something he already knows, right? I didn't know what a pigeonhole was. I had a vague notion what a pigeon was. A bird of some, I was pretty sure it was a bird. And so after 10 or 15 minutes, it's not clicking at all. He says, okay, forget about the pigeonholes. And he says, okay, it's like, he says, arrays are like post office boxes. And now, I was raised in a rural San Diego County. Now here, you get mail delivered not quite to your house, but to a box on the street right in front of your house, right? That's not the way mail was delivered in Ramona, California, where I was raised. So, there was a long road that you lived down, and at the end of that road was everybody's mailbox. And so, there was 20 or 30 mailboxes here at the end, and they are, what was an array? It was an organized collection or something like that. Anyway, this was not an array of mailboxes. So when he says post office box, I'm thinking mailbox. And there's like 30 of them, and they're all different sizes, and they're, they're on posts. Some of them are leaning over, and it's definitely not organized. I had been to the post office a time or two, but I didn't make the connection that those square boxes in organized rows and columns, that even what those were. So when he says post office boxes, I'm thinking these rural mailboxes. Anyway, after about a half hour, I'm in tears. I can't understand what he's talking about. I think I'm a moron. My father's in tears. He thinks my son's a moron. And we gave up. We just gave up. I didn't learn about arrays that day. So I tell you that just to remind you to remind me that when you're first exposed to this idea, it can be kind of difficult. But the good news is I am an excellent teacher. And so I'm going to help you get this today on the first time. All right. So we'll come back to the data that we'll be working with today. But first, let's jump into VBA and just see how do we make an array of variables. It's really easy. So Alt F11. Okay, so I'm going, I have all my debugging stuff open. I'm going to close these and open a module. So insert module. Here we go. I'll just call it sub X for now. We'll give it a name later when we actually get to what we're going to do with this one. So let's say I want to declare a variable that holds somebody's name. I would say dim name as, what type should we use? String would be good. Okay, this is declaring a variable. If I want to declare an array, I want to declare an array of variables, a whole bunch of variables all at once. I might come here and say, you know what, I want more than one. I want a bunch of them. So now, all I've done different is put a number in parentheses right after the name of the variable. And now I have created an array of variables. And so instead of, so before I might have just said, name equals Nephi. Now it is not enough to say name, because now name doesn't identify each individual variable anymore by itself, right? To get to the variable, what do I have to do? I've got to give it a number. How many variables do I have here? Oh, which one am I talking about? How many do I have? I don't have 99. I have 100. It turns out that the number that I'm putting here is not the number of variables. It's the top index that I'm putting here. And the bottom index is 0. So we start arrays counting at 0. Now, it turns out, let me just come up here real quick. We got option explicit up here. There's another option we could put, option base 1. If I say option base 1, we go, oh, you know what? We're going to start our arrays counting at 1. And this might be tempting to put here, but we're not going to do it. This tells the interpreter, hey, when you see an array declared, don't start counting at 0, start counting at 1. We're not going to do this, but I want you to know that it's there. The reason that we're not going to do this is because if you have learned how to work with, because in almost every other programming language, arrays start at 0. And most examples you'll see when you come across someone else's code, arrays are going to start at 0 because that's the default. So why don't we use 1? Because it's easier. It really is easier to think of it as 1. The reason is that if you learn 1-based arrays, and that's how you learn working with arrays, every time after that for the rest of your life, when you bump into a 0-based array, it will be confusing to you because you learned it wrong the first time. So it'll be a little bit more painful for us to learn it with 0-based arrays today, but it'll be more healthy for you in the long run. So we'll use 0-based arrays. Incidentally, they don't even have to be 0 or 1 based. Option based 1 is the only thing you can do. You can say option based 1 or option based 0, but you could say, you know what? I want to go from 50 to 99. And now instead of starting counting at 0, I start counting it at 50. And I've never seen this in any other language besides VBA. Well, I guess the other variants of VB do it as well. But we're going to just put one number there, and we're going to assume that we're talking about the beginning as 0. So I've got 100 variables here, and now I have to tell it which one I want by putting a number. I want the number 3 variable to be Nephi, or I want the number 1 variable to be Nephi. And then, as string name, what's wrong here? I don't think name is reserved. Maybe it is. Let's call it names instead of name. Oh, apparently name was a reserved word. I never knew. Okay, now I could print that. Debug.print name sub1. So we can just think of this as just shorthand for creating 100 variables that names look like this. But what's magical about this now, let's be names. What's magical about this now is that the name of my variable is a hybrid. So instead of referring to it with a literal, I can refer to it as a string. So let me dim I as an integer. Let me say I equals 1. And then I will print, I'll write to I, and this should do the same thing, print that value up there again. So the whole point is now I can put any expression in here that evaluates to a valid number in the range between 0 and 99, and I will have, be able to identify that. Can you guess where this is going to come in handy with what else we've learned in here? The idea of a loop, yeah, because now I can have one line of code. Let's just do it. Let's put Nephi in all of these. For I equals 0 to 99. Next. In fact, let's make another loop. We could do it in the same loop, but we'll make another loop to print these off. We'll print I, comma, and 99. That should print off 99 copies of Nephi. We have put the string NEPHI into all 100 of those variables. As this went through, right? It changed I, started at 0, next time through it was 1, then it was 2, then it was 3. It filled all of those up. And then when we print it out, of course, it prints it out. Questions? Yes?
If you didn't specify, if you didn't put the parentheses where you have name when equals Nephi, name equals Nephi, did that assign Nephi to all of them?
Oh, so it wouldn't it be great if I could leave this off and it would just automatically fill those up with all of them? It does not. In fact, it should be an invalid syntax. Can't assign to an array. That's pretty good. That's actually pretty good. I like that. Wow, it doesn't have a number. Oh, it's because it's not a runtime error. It's a syntax error. Oh, yeah, syntax error. Okay, so name sub I. Yeah, you have to give it the index. Now, what I really want to point out here, and some of you who are coming from other languages, you're going to be at a disadvantage here because you are used to an array being an object. That arrays have properties and methods like arrays have pop and push, or they have properties like length. You don't have that here. An array is just a collection of variables. So you never ever say array dot, and this will be your tendency is to say, oh, I want the value of that. That's no good because it's not an object. There's no properties. The only thing it is it's a bunch of variables. And you think about it, a property is like a variable built into an object, right? It's a little place to hold a value in an object. And all we have here are the properties, right? Each element is just like a property. So you don't have to say what property is. It's just a value that I can hold. Okay? So, okay, so far, how are we feeling? Just show me on a show of fingers from 0 to 5. How are we doing with arrays? You know, am I seeing 4s or 5s? I'm seeing 5, 5, 5, 4, 2. So a little bit, some of us are going, not quite there yet. We'll do some extra work here. But the point, and in fact, what might be helpful is to look at it this way, is that I could also say, once I've declared this, I've got a whole bunch of different variables And you can actually think of them as being named, including the number. So I could think of them this way, right? 1, 2, 3, 4, 5, 6. So this is kind of the same thing that happens in the first 7 steps of this loop. You can almost think of that as being the name of the variable. I just created 100 variables, and that's the name of one of them. That's the name of one of them. In fact, you could use them just as if that was the way. But where they become powerful is when I say, you know what, I want to treat all these uniformly. I can now put them in a loop and use an index variable to control which one I'm talking about each time through the loop. Questions? Yeah.
So I'm just thinking about the way that you used arrays before. So say the variables, they have locations and stuff. Like for example, like cell references or addresses in the collection of cells and that.
So the question is, I don't understand the question.
So like you can maybe
We're going to show some examples. We'll spend the rest of the day working with it. In fact, we're going to do today on arrays. We're going to do Monday on arrays as well. Okay, so that's kind of the introduction to arrays. We'll actually do some work to solve a problem. Let's take a look at the problem we're going to solve. So suppose we answer this question before I talk about this. Go ahead. Yeah, so can I have an array of arrays? And that's the way in some languages that we do multi-dimensional arrays. And as you'll see here, actually multi-dimensional arrays are first-class citizens in VBA. So we can make a multi-dimensional array. But one of the things that's different is that in VBA, all of the variables in your array must be of the same type. They can all be string, they can all be integer. Now, it turns out, we're not going to do it in this class, but you could make what's called a user-defined type, where I say this one variable has, it's actually got like 3 variables built into it, a string, an integer, and a long, and I can make an array of those. So if I really wanted kind of different data types, I can still do that, and we'll do an example of a multi-dimensional array today, okay? So what we've seen so far is just one dimension, right? You have one number and it gives you just one list, but you could like make a grid of these variables instead of just a vector. Okay, so now let's suppose that you've taken your first job. How many of you already have a job lined up? You're just waiting to hopefully pass this class so you can graduate. So the rest of you, you're not quite sure where you're going to work. You might get hired by the Starwood Corporation, and that is then the company that we have this worksheet from today. So you're familiar with the Starwood Corporation, even though you don't know it, because you've stayed at their hotels. If you've ever stayed at the Sheraton, that is one of the properties of the Starwood Corporation. If you've ever stayed at the Westin, that's, so Starwood owns hotels, and some names you're familiar with. So the Four Seasons, the W. I never knew there was a big hotel called the W in New Orleans. I never knew that was like a chain. I just thought it was just one hotel, but it's a whole chain. So so you've been hired, and great, you're going to graduate here in April. And now he says, listen, we want you to actually start, let's see, April, May, June, July. We don't want you to start till the end of July. So you're going to come here on August 1st. But we're paying you now. As soon as you graduate, we're going to pay you. And here's what we want you to do. No one knows we've hired you yet. You're working for the Western Regional Office of Starwood Corporation. We've got a whole list of hotels here. Some of these hotels are doing everything perfect, we think, just doing a great job. And some of them we're thinking about closing. And so we want you, as an unknown employee, to go to all these hotels, in the next, 3.5 months before you start here. And we want you to eat at all the restaurants there, and work out in the gym and go to the pool and sit in the sauna or whatever, and visit the masseuse. Make sure you spend some time with the masseuse at every single one of these, and then keep track of what they're doing right and what you think they can improve on, and then we'll kind of use that to get going on this project when you get here. And so you think this sounds great, or you might be thinking, well, wait a minute, I've got I've got a spouse and some kids. I don't want to be gone from them for 3 months. And no problem. We're going to rent you a van and take the family with you. We'll give you the corporate credit card and spend, great, have a great time. And so you're thinking, okay, this might be all right. So your next question is, well, what order should I go to these hotels in? And I don't care. We don't care which order you go in. You just got to go to all of them, before you start. 3.5 months. There's 36 of these. Okay. So now you're great. You're going to do it. You decide to start in Salt Lake. That's the closest one here. It's a Sheridan here in Salt Lake. Now, if you could describe to me in English a characteristic of the route that you choose, what would you like this route to be? And there's things you can say. I want the most scenic route. You can say that. Or you could say, I want the most blank route. What do you think? Shortest route. You come up with that pretty quickly. Because why? Because every minute in the van with the kids is one less minute with the masseuse, right? So you'd like this to be as shortest travel time as possible. So how are we going to do it? How would you solve this problem? What was it? Yeah, you just Google it, right? Because in fact, you can go to Google Maps and you can put several destinations onto Google Maps. Google Maps won't let you do 36, and you'll see why. You can't do 36 on Google Maps. So, but what you might do is you might maybe just print out a map or buy a map of the Western United States and kind of plot where all these are. And then you could just draw a line and say, you know what, I kind of like this way. And you know what, that would be a pretty good, you'd end up with a pretty good solution to the, so you can draw a line that goes through all these dots, following the roads, and you go, that's the route I'm going to take. But what if you're not just doing this once, but what if you're Amazon, and you're just recently, I don't know when did Amazon start delivering stuff. It seems like it's only been the last couple of years when they started delivering. So you've got to start delivering stuff, and you've got to solve this problem tens of thousands or hundreds of thousands of times every day. You're Federal Express. This is all you do is decide what direction to drive these trucks every single day. You got these deliveries to make. What direction should you go? You can't do it with paper and pencil then. Right? So we got to have some algorithm. We've got to come up with an algorithm to do it. And as you guess, we're gonna come up with an algorithm today. But so what might truth is, for this solution, paper and pencil would be pretty good. But if we're gonna make an algorithm, what might you do? Any thoughts? How would you go about it? I'll give you the step one, go to Salt Lake. There's the first step. So how do you decide where to go next? Yeah. Okay, so I'm in Salt Lake. What's my next step? You kind of gave me too many steps there. Okay, so you're saying from Salt Lake, let me see what all the other distances are. And in fact, that's what we're seeing here, right? This chart that we have up here is going to give us the road distances. So let me just copy this part here from there down to here. If I look right across this row now, I've got all the distances from Salt Lake. So from Salt Lake to Los Angeles, 691 miles. From Salt Lake to Salt Lake, 0. That's why that one's blank. We look to Las Vegas over here. Where's Las Vegas? Should be the 7th one. 1, 2, 3, 4, 5, 6. Right in here somewhere. Here it is, Las Vegas. 425 miles to Las Vegas. And it turns out Las Vegas is the closest one. So this sounds like a pretty good algorithm. We start in Salt Lake. Who's closest to Salt Lake? We go to Las Vegas. And then what? And then finally, who's the closest to Las Vegas? But incidentally, the closest one to Las Vegas? Salt Lake is the closest one. That must not be true. Las Vegas, maybe it is. It kind of looks like this must be wrong. Maybe that's right. I don't know. But anyway, the problem is we don't want to go back to somewhere we've already been. So we really want to find the closest one that we haven't been to yet. And then that's a pretty simple algorithm. And then we'll just apply that algorithm over and over again, until we get down to the very last one. And it will work every single time. So it turns out this problem is a famous problem. What's the general name for this problem? Yeah, it's a traveling salesman problem. And humanity has been trying to solve this problem since the 1700s. Mathematicians spend their whole career studying the traveling salesman problem. And for all the effort we've put into it, there is only one known solution. One algorithm that is guaranteed to give you the shortest route. By the way, the one that you described for us over here has a name. It's called the next nearest city algorithm. And it is virtually guaranteed not to give you the shortest route. But it's a route you can calculate. It's actually the one we'll do here in class. It's a pretty good route. But you'll see that it'll be a little bit dissatisfying because after we build it, you'll go, oh yeah, I see the problem with this route. I could have done better with a pencil and paper. But what is the only known algorithm? You could guess what it is, even if you know nothing about it. What's the algorithm guaranteed to give you the shortest route? You guys are smart. I bet you could figure it out. I mean, you don't have to calculate it, but just describe it. Oh, come on. Yeah, go ahead. Nope, that's not going to do it. Go ahead. Yeah, that's it. Calculate every possible route and pick the shortest one. That is the only known solution. So how could you spend your whole career on this and never come up with anything better? Well, because we can, what we do is we can figure out ways to throw away huge parts of this problem and say, you know what, this whole space, no reason to look over there. We know that's not the shortest route. You know, so we can do things to get it to where we say, you know, we're 99% sure that this is the shortest route. But to get to 100% sure, the only way still is to calculate all the routes. So when I first decided to use this as an example in this class, it was years ago. I love this example for teaching arrays. Let's go ahead and create a new sheet. So I said, all right, I've got a computer here. I'm just gonna go ahead and calculate all the routes. It was this very problem, 36 cities, 36 locations. And I think I started in the morning trying to write the code that would do this, and I'm embarrassed to say it took me till about noon to get to where I think, okay, this is finally right. This is going to run, and I set it to run, and it took a while to run. And by the time it was 5 o'clock, I was getting ready to go home. It was still running, and I thought, it's taking a while. I'm going to go ahead and just let it run overnight, and it'll be done by I come in the morning. Came in the morning, it was still running, and I thought I must have put myself into an endless loop somewhere, and so I killed it and kind of looked at it, and I couldn't find the endless loop, and so I said, let me just calculate how long it's going to take. And it turns out my computer, I was pretty surprised, my computer could calculate 5,000 routes in a second. I thought, this shouldn't take too long to get through this. Okay, so someone here, I'm always surprised that someone knows the answer to this question. How many possible routes are there? 36 cities, how many possible routes are there? Yeah, 36 factorial. It took me like a half hour to figure out it was 36 factorial. I'm not quite sure why you guys have that on the top of your head. That's amazing to me. Okay, fortunately, here in Excel, we've got a formula called factorial, F-A-C-T, and we can put 36 in there, and it will tell us 36 factorial. Now, I was never that great with scientific notation, but I'm thinking that's a pretty big number, but let me change it to decimal so I can understand it. Like a comma. Ooh. 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 There we go. Okay. So we don't need the decimals on this. In fact, let's just make this whole column common. Get rid of the decimals. Okay, excellent. That's how many possible routes there are. I don't know how to say that number. So let's think about it in terms of seconds. So this is an older computer. So let's say that maybe it could go twice as fast now. So let me take this and divide it by 10,000. And that's how many seconds it's going to take for me to solve this problem. So still, I don't know what that is. Let's divide that by 60. That gives me minutes. Divide it by 60 again. That gives me hours. Let's divide that by 24. That's how many days it's going to take. Divide that by 365.25. That's how many years. I'm not solving this with my computer. I'm going to need more processing power. Now, I read not long ago that the 1 billionth PC had been produced. Kind of a big thing, the 1 billionth PC. So a lot of those are retired by now, but let's use that as a surrogate number for processing power of humanity. So let's divide this by a billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoa. If I dedicate all of humanity's processing power to this, that's how many years it's going to take. What's the best scientific estimate we have for the age of the universe? Anyone know? Yeah, it kind of ranges from somewhere around 12 billion to 20 billion. A wide margin of error there. Let's be conservative. Let's take that, divide it by 20 billion. Did I get that right? Equals this, divided by 20,000 million billion. Oh, that is a number I can say. That is 58, let's see. That's thousands, that's millions, billions. So yeah, okay, so if we dedicated all of humanity's processing power, we could solve this problem in 59 billion times as long as the universe has been in existence, right? You could drive the worst route way faster than you could calculate the best route, right? So we're not gonna solve the problem. This is why Google Maps won't do it. When you say, oh, yeah, here, plot these 36 cities, it'll say, we'll do 5, for you, maybe 6. I don't know what they do these days, but you're not gonna get okay. And I think there might be a solution here because I'm looking at these numbers and I think it looks kind of like Montana. So maybe we should start in Montana. I don't know. Okay, so that's going to be then our chore. We won't come up with the best solution, but we will calculate a reasonable solution and we'll use the next nearest city algorithm. And as you may have guessed, we will use arrays to implement this algorithm. So let's go ahead and come back to our code and get ourselves started. So instead of doing this with names, why don't we call this first one hotel? And sometimes I like to put them in plural or singular. I guess I'll call it hotels. And instead of 99, what should we put here? We have 36 hotels, so what should we put? 35. Excellent. And then let's have this array here go from 0 to 35. And we'll go ahead and put Nephi into all these to start with. And we put hotels in here. And I guess we got this one down here. We'll print them. It's already written. We'll go ahead and print this one off as well. 35, print I and hotels. All right, okay. So we really haven't, and I'm gonna call this initialize, or maybe just init, I-N-I-T. Okay, so now if I run this, I should see Nephi now, but 36 times instead of 100 times. That's the only real change I've made here. Except I must have deleted that by mistake, dim I as an integer. And there we go. Now what I'd like to do then is instead of just put the same value in all my hotels, I want to read that value off of the worksheet. Well, good news, I've got a worksheet here called distance, and right here in the column is the name of my hotels. So I've got A, just here in column A, the very first column, starting in row 2. That sounds great. So, oh, and in fact, let's see, Control R. If I look here, I'll even notice that I have named this worksheet to have the code name be properties as well. So I don't have to declare a variable and bind it onto the worksheet. I can just refer to it by the reasonable name that we have here. So instead of hard coding this, when hotel is, or when I is 0, when I'm writing to the first element in my array, the first variable in my array of variables, I'm going to look at my properties sheet. And I'm going to look at cells, row number, I, now it starts in 2. So when I is 0, I want to be looking at row 2. So I plus 2. When I is 1, I'll go to the next one and so forth. And it's column 1, and I want the value of that. So now we've got a loop here, and it should increase. You know, we'll start off by looking at the number 0 position in hotels, the first spot in my hotels array, and then looking at 0 plus 2, the second row, column 1, and just read those values in. So if I run this, it should, Windows, there we go. It should just spool off the names of the hotels. And, oh, because I'm printing, what have we done here? Row to column properties. Why am I getting numbers? Oh, is it column 3? Column, oh, I'm on the distance. Sorry. Yeah, I don't want properties. I want distance. Yeah, sorry. Distance is the right one. Sorry. Thank you for figuring that out. I'm not sure how long that would have taken me. So this is distance. That's better. So we've got the names of our hotels here. So big deal. We now have those variables, the hotels of the names in variables instead of working on the worksheet. Oh, folks, could we solve this problem never using an array, but just working on the worksheet? Yeah, totally. I mean, it's like I've got a great size array out there. I could just, you know, I got a whole bunch of them that I could use. In fact, when I was first designing this course, I thought maybe we don't really need to talk about arrays. Because you could get by, you could do great things, never even understanding what an array is. But the reason that I decided to bring it on and spend 2 days on it in the course is twofold. Number one, some of the properties that we're going to have to deal with objects that we will manipulate later in course are themselves arrays. We're going to have to work with properties of objects that are arrays. The property is an array itself. And the second one is wherever you go from now until the rest of your life, you will be the VB expert. And so people will bring their VBA problems to you. And it'll be like this. You know, 2 years ago, there was an intern here and wrote some stuff from VBA that was great, but it quit working, and none of us are sure why it doesn't work. And so it'll be like your job to look at someone else's code, which is never a fun experience, especially as an intern, because he wasn't very good at it. or he or she wasn't very good at it. And so, but it's really common for other people to use arrays. And so I thought, you know, this is something we got to spend some time on. Okay, so we've got the names of our hotels, and ultimately we're going to have to print out a list of hotel names in an order that we want to be able to go to these hotels in. Question here. Yeah, let's clear these things off. I think we're good. You're saying you're getting type mismatch when you run. So remember, what type mismatch means is that you're trying to put something into a variable that's of the wrong type. Like you're trying to put a string into an integer or something like that. Most of your numeric types will convert. You try to put a long integer into an integer, that will be an overflow if it's too big. Or like a floating point number into an integer, it'll round it for you. But did you find it? Pity. We're going to make some pretty substantial changes to this code, so maybe it'll get fixed in the changes that we make. In fact, let's do this. Right now, kind of unfortunately, we're wired up for a 36, a problem size of 36. Now, this code that I'm writing, it's reading the data off this worksheet. You know what? What happens if after I have such a great time working for the Western region, I think, hey, let's go do it for the South Central region. And so, you know, we go over there and propose, hey, I'm going to come over here and go to all your hotels, whatever. And they say, great, we'll love to have you do that. So now I don't have 36, I've got 28 properties. I don't want to have to come through and change my code. I just want to drop a new sheet in here. So is it possible for me to declare the variable after I figure out how many sheets there are? So let's give it a shot. Above this dim statement, I'm going to come in here and say hotel count. Dim hotel count, hotel underscore count as an integer. Now hotel count, this is going to be kind of an ugly expression, but I think you'll be able to deal with it. I'm gonna set this equal to some range. I'll specify the range here differently in a minute, but I want to refer to the cells of that range and count them. So I'm gonna say, all right, I've got some range. We'll identify the one we want here in a minute, but I just want to know how many cells there are in the range. So here's how I'm gonna figure out how many hotels I have. This is gonna be a two-dimensional range, right? I'm not two-dimensional, it'll be a multi-cell range. So I'm going to put a reference to one cell here, so distance dot range, let's see, starting right here in A2. So if I start in A2 and do control down arrow, I should be able to get to the one I'm after. So distance range A2 is my starting cell, and my ending cell is whatever cell I would be on if I was on A2, and hit control down. Ooh, I should not have hit down arrow. I left the line there because it's a little bit hard to see when it gets all collapsed in. So I've got a range that starts in A2, ends in whatever cell it would be on if I was on A2 and hit end down or control down. And then I'm referring to the cells in that range and asking for the count of those cells. And that should give me 36. That's my hotel count. So now that I've counted that, I would like to put right here instead of 35 hotel count. -1, right? Because it's going to start at 0 and a count of 36 hotels, I get but 35 here. This looks beautiful. I'm going to run it and we'll see that it will not work because what I put inside the parentheses of my array has to be a constant expression. Well, that just stinks. What does that mean? It means it can't be a variable that I calculate. It's got to be a number. Alternatively, it could be a constant that I've defined. You know, const equals 35 and then use the constant here. Or even const equals 36 and then that constant -1 would work. And here's the reason, is that every dim statement, and none of these dim statements are executable. Right? On executable lines, you can put a breakpoint. Whoops. I'm going to put a breakpoint right here. I'm going to put a breakpoint down here. All these lines I can put breakpoints on. But if I try to put a breakpoint on a dim statement, no can do. Click all I want. Maybe I'm not clicking hard enough or fast enough. I don't know. You can't put a breakpoint here because this line doesn't execute. What happens is when the interpreter says, all right, someone wants us to run this subprocedure, it looks through the whole subprocedure, finds all the memory declarations, and it says, this is the memory we're going to need, and it says I got to allocate all that memory before I start running. So the problem is that the dim statement actually gets, it's not executed, but it gets processed before hotel count has a value, right? This line, even though it's after this line, it actually gets taken care of before this line ever runs. So I can't do it this way. That's a lot of work to say you can't do it. Well, it's work we'll be able to reuse, because what I could do is declare this above. Watch this, this is magical. And I'm not going to, did I cut that or I copied it? Oh, it's right here. So I got two copies. We'll have to fix that in a minute. Instead of telling it this, or even instead of saying 35, I'm going to just put opening and closing parenthesis with nothing in between it. Now, what I've done here is I have told the interpreter, all right, Mr. Interpreter, I'm going to be making an array at some point in the future. It's going to be called hotels. It's going to be a string array, an array of string variables. And it desperately wants to know, how big is it? And what I'm telling you, I'm not going to tell you how big it is now. I will tell you when I'm good and ready. And it says, okay, all right, I guess I'll wait. And it kind of says, gets ready to be able to use the array, but it doesn't actually allocate the memory until later. I come down here, and instead of dimming it, I redim it. But when I redim, I don't give it the type. I give it the type when I dim it up here, but when I redim it, no type is involved. And you'll see that redim is an executable line. So I can, this is when it actually happens. So this will allow, this should now work. Again, let me go ahead and run this. And this should spool off all the values, because now it's being declared as what we call a dynamic array. And then later we can give it its value. In fact, later on we can change it to a different size. Or we can change it however many times we want. Go ahead. Oh, yeah. But now this is hard coded for 35. So we could change it to say hotel count -1. But I'm going to do it a different way. It turns out you can ask an array how big it is. Let me put a breakpoint right here. I'll run to here. So now, because I'm in break mode, I've already allocated the memory. I've already redimmed it. I can ask for the upper boundary of hotels. And it will tell me what its upper boundary is. Incidentally, you can ask for the lower boundary too, but since we're just always making it 0, we probably won't need to do that. But you could ask for the upper and lower boundary. So instead of having 35 hard-coded there, I'm going to say, you know what, just go from 0 to the upper boundary of the array on both of these. And so now we've generalized that code. So, you know, whatever set of data we drop onto that worksheet, this code will now adjust itself to work with that. That's nice. Oh yeah, that's going to be a problem. Let's change it to upper boundary. Thank you. Upper boundary, upper boundary. Yeah, for I equals 0 to 0 doesn't really run very many times. I think it would run once. Yeah, it would run once. Okay. So we've made, so far the idea of an array, not too bad. We've made it a little bit more complex by saying you can set the size through code instead of having it. But let's just poll where we are right now. Just show me on your fingers, how are you feeling about arrays so far? 5 means feeling great. 4 or 5 feeling great. 1 or 2 means this is witchcraft somehow. I'm not quite sure what's going on here. So I'm seeing mostly 4s and 5s, a few 3s, and 2 or 1 or 2 2s. Go ahead, question here. Hotel count. The question is, shouldn't my upper boundary be about hotels, hotel count instead of hotels? And the answer is no, because hotel count is just an integer value. I could say I want to go from 0 to hotels count -1. Hotels count is 36. And so this would go 0 to 35, which is what I want it to do. That would be okay, but I'm just taking a different route there by saying, instead of using the variable that I use to figure out the size of the array, I'm going to ask the array what its upper boundary is. So there's a function called ubound. I give it an array, and it tells me the upper boundary of the array. Yeah, the other way would work just fine too, but what you're going to see, in fact, we'll do that next, is that we're going to need more than one sub-procedure to solve this problem. We're going to need two sub-procedures, and so we'll want to be able to declare this array somewhere that we can have two different sub-procedures referring to it. So that's going to be next, but there's a question here. So when you run it, you're getting 36. Have you, so no, upper bound should give me 35. It is the upper boundary, not the number of the hotels or number of elements in the array. But what that means is when you redimmed, you probably did not subtract the one off here. So yeah, we're starting to figure out how many hotels there are, but when we redim it, we've got to subtract one off of it to get us to the right place. Okay. So far, the only place we've ever declared a variable, and when we declare an array, we're declaring variables, just like any other variables. The only place we've ever declared a variable is inside of a sub-procedure. Now, when we do that, when the sub-procedure starts to run, it says, oh, we've got to go allocate some memory. It asks for the memory for the operating system. Operating system says, here's some memory for you. We then use it, and when we get to the end sub, what happens to that memory? It's released back into the wild. The interpreter says, we're done with the sub-procedure. We don't need the memory that was associated with it. It gives it back to the operating system. It says, thank you so much for the use of your memory operating system. You now can do whatever else you want with it. I'm done with it. But that means the value is not accessible between sub-procedures. If I want it to be accessible between sub-procedures, I'm going to declare it not inside, but outside of the sub-procedure. And it has to be up at the top of the module. So by declaring a variable at the top of the module, now it will get allocated as soon as any code in this module runs. And as long as code is running in the module, it'll leave it allocated. So I could run this sub-procedure, call another procedure, call another procedure, call another procedure. And as long as those are running, all of the memory is still allocated, doesn't get released. And all the sub-procedures can see that variable as if it was declared inside of it. So the general rule is you want to declare your variables inside your sub-procedure unless there's a really good reason to put them at the module level. And in this case, we're going to have two sub-procedures probably three sub-procedures are referring to this array of variables. And so we'll just declare it up here. So now we're set up pretty good. All right, so we've got the names of the hotels. What else am I going to need? I'm going to need at least one more array, maybe two more arrays to be able to figure out what our route is going to be. So what other array might we create to help us figure out the route or to express the route that we're building? Go ahead. What do you think? Ah, we're going to need an array of distances. Yeah. So let's go ahead and declare that one. Dim distance. I can't call it distance because I have a worksheet called distance. So I'll just call this dist. And we'll make this a variable length array as well, a dynamic array. And this one will be as integer. Okay, what else? Any other thoughts? Yeah, go ahead. Okay, so we might have a list of hotels that we've already visited. And in fact, if we did, that would be like building the route that we're making, right? So as soon as we go to Salt Lake, we'll plug that one into our list of visited hotels. And then the next one that we go to, which will be Las Vegas, we'll plug that one in. And so I'm going to call that route. I like it. So let me dim route, or maybe it's route, depending on what part of the country you're from. And this one, now this one could be a string or it could be an integer. I'm going to use integer here. And what I will put in it now is not the hotel's name, but the hotel's number in the hotel array. So these will be numbered between 0 and 35. And then if I want to actually make them into, to show the name of it, I just have to pass that array or that index number to the hotel array, and we can change that number into a variable anytime we want, into a string anytime we want. Okay, so this looks pretty good. We've got our hotels initialized. We now need to initialize the route array and the distance array. And I've actually given you a picture on the arrays worksheet over here. Now, this is, of course, these are ranges, but I've just drawn this picture in here so we can kind of think about what these arrays might conceptualize these arrays in memory. So here I've got my hotel array. It's got an index number that shows us what the index number for each one of these slots, with each one of these variables in the array is numbered. And now I've got the route array, but I've made this route array of type integer. And the way I'm showing it right now, there's no value in all these integer variables. Is it possible to have an integer variable with no value in it? The answer is no, right? If you have a numeric variable, it has to have a number in it. What will it default to? Yeah, it'll default to 0, but you can't make it blank. It's got to be 0. So when I create this, this is actually going to be full of zeros. I'm going to put a 0 here, and let's fill that down. Now, the little problem that we probably wouldn't notice as we were working on this until next time we got together, but I want to solve it right now because it's part of the problem that we're working on. We're using this route array to tell us which hotels we've been to. And what is it saying right now about which hotels we've been to? Yeah, that's one in Los Angeles. This hotel number 0 is a valid one. And so what it's saying right now, we've been to Los Angeles. We must like Los Angeles because it's the only place we've been, and we've been there a bunch, right? It says our route right now has Los Angeles, Los Angeles, Los Angeles, Los Angeles, Los Angeles. And so because we're going to be using this array to answer the question, have we been there yet? We better get these zeros out of here. Otherwise, we'll never schedule ourselves to go to Los Angeles because it thinks we've already been there. So what should we put in instead of 0? 2 won't work, clearly, because 2 is also a valid one. 13 won't work. 35 won't work. What should we put? Yeah, 36 is no good either because we might have a 36 size problem, but we're never going to have a hotel named -1. So I like -1 as a choice here. So here's what I'm going to do. Right here where I'm putting in the names of my hotels, I'm just going to initialize my route array as well. So route, sub I equals -1. And so, yeah, this is one that the truth is, when I first built this solution, I did not anticipate this problem. I wouldn't expect you to see this problem. But because we're initializing the arrays today, I wanted to go ahead and put that one in. That will save us some time on Monday. But let me just go ahead and fill that in. So now we've got that array initialized as it is. Question? Oh, yeah. So what you're saying is that we've already counted hotel count. Yeah, so the thought is we could just put hotel count here because one whole hotel count is one above what the highest index would be. Hotel count would work as well. Yeah, but it's for the same reason that -1 works great, is that you'll never have a hotel in your problem with that number. And that's what we need. Because we'll be asking the question, have we been to Hotel 7? And we want it to be able to say no. Have we been to Hotel 0? We want it to say no, you haven't been there yet. Okay. So now we have one more array to fill up. Oh, no, we have to redim this one. We haven't redimmed this one yet. So we made it dynamic, but we have to give it a size. And I'm going to redim that one right here. It'll be just exactly the same as our hotels, and so we'll make this route. Now we've got to do our distance array. So let's redim it. Now, but what we're going to see is that when we go to redim dist, it's a little more complex. It's a little more complicated because, and this is what we have here is we have the. Did we talk about these already? The road distances. These are the road distances between all of these hotels. And what I'll have is this needs to be the other half. I put a note here. It's the other half of this array. In fact, if you've ever traveled in Europe, when you buy maps, they very often have these kinds of tables at the bottom that show you, maybe in the United States for all I know, but it will show you the distances between major cities. You know, how far it is from Paris to Salzburg or something. So you've got all your cities along the top and the bottom. And then you'll have distances. You only need distances on half the array. But what do? Have you seen it? They'll put miles on part of it, for you American tourists, and then kilometers on the other part for the rest of the world there. So, but we're going to want this to be filled in all the way. Let me just copy these values here. And when we build our solution, I'm going to paste transpose these. I want these to be going all in the same one because I have to ask the question, what you said, who said the next nearest city? I forget who gave us the algorithm. Over here. So we've got to be able to look at, when we're on hotel number 7, what's our next nearest hotel? And so if I don't fill in this part of the array, I've got to go down and then turn and go over. And it would be so much easier if I could just go all the way across. Am I saving any memory by leaving these undefined in my array? No, because each one of these is going to be an integer variable, and so they won't be blank, they're going to be 0. I'm not saving any memory by leaving it unfilled. And it will make me it'll make it lots easier if I can say, ah, I'm on row number 7. When I'm trying to figure out how close, who's the next closest one, just looking at row number 7 will be better than having to go kind of down and then over. Okay, so that's what we've got to do. Our source data is just this diagonal. So we're dealing with it this way, but we're going to have to kind of fill it in separately. So let's go ahead and see what we have to do to fill this one in. Oh, to initialize it. So this one's going to be not just a vector of numbers, but it's going to be a grid of numbers. And so I will initialize this one to hotel count -1 and hotel count -1. I'm going to give it 2 indices. Now in this problem, it happens that they're exactly the same size. It's a square, but it doesn't have to be. It could be a rectangle, right? It could be 4 variables wide and 27 variables tall. But now I've allocated, this is a 2-dimensional array. So now, let me just go ahead and run right to here and pause. Now, if I'm going to put a value in distance, I've got to say dist, and I've got to give it 2 values. I've got to say row number 0, column number 1 equals 693. I'm not sure that's the real value that belongs in there or not. But that, oops, I'm not question mark. I'm just going to execute that. So that puts it in there, and then I'm going to ask what dist 0, 1 is. And that'll tell me that's the value that I put into it. So now, because I declared this with 2 numbers, I have to supply 2 numbers for each one, right? And it's like a Cartesian grid here. I've got, oops, let me go to my arrays. I've got the first number tells me which row I'm on. The second number tells me which column I'm on, and it gets me to a particular one. It turns out it's not really organized into rows and columns in memory. It's one long stream of values in memory. But I can think of it as being that way. So is it rows, always row first and then column? Well, could be column first and then row. As long as you're consistent, it doesn't matter. Because it's really just a way for you to organize it. You could think of it this way. You could say, no, 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 no. I don't have rows and columns. What I have is I have big boxes and little boxes. And in this case, I've got 36 big boxes. And each big box has 36 little boxes in it. And so the first one tells me what's my big box to look in, and the second one tells me inside that box which is the little box to look in. Right? So you could, how you want to visualize it is fine, doesn't really matter, as long as whenever you put in 0, 1, when you ask back for 0, 1, it's going to give you the value you put there. I like to think of this as a grid. To me, that's the easiest way to think about it, because I'm so used to working with grids in Excel. So let's go ahead and just fill in this first row. All right, so I'm going to go ahead and come down here. And before I do the printing, I've initialized these. And I could actually make this work kind of inside this one, but I'm going to start again just to make it a little clearer. So I'm going to say I'll just reuse I, for I equals, Now, I don't need to write, this is going to be 0 here. I don't need to write that because it's already 0. So I'm just going to go from 1 to 35 on this one. For I equals 1 to 35. And I'm going to say here now, dist, row number 0, column number I, equals, and then let me go ahead and read off of that distance sheet. Let's see, it's going to be always going to be row number 2 for this first row, and then column number I plus 2, I think. So when I'm looking at row number 0, yeah, it's going to be when I is 0, I want to be putting this number in. No, I is not going to be 0. I is going to be 1. So I want, yeah, so when I is 1, I want column 3, so it's I plus 2. Yeah, so that looks right. So let me go ahead and run that, and I'll put the breakpoint down here. So now I should be able to look at dist sub 0, 1. This should be, I think 693 is the right value there. No, it's 691. The next one over sub 2, 374. There it is, 374. Then 385. I think we've got him. We got him in there. Looks great. Let's look at the last one, 35. 1039. Whoa. 1,039, that's great. That is just great. But we've only got the first row. If I look anywhere else in this, in fact, if I look at 0, 0, that should be 0. That's how far it is from Los Angeles to Los Angeles. But if I look on any other row besides this one, I'll look at row number 1, column number 3. That's 0 as well because I've only done this first row. I got to do that, something similar to that, 35 more times. Whew. Hey, if I have some code that is pretty much the same, and I want it to happen a bunch of times, what do? I make it a loop, but I've already got a loop. Yeah, I need this loop to be inside another loop. Oh boy. For that, I'll need another control variable. So let me just dim k as an integer. So now I'll say for k equals, now that's, I'm going to use k to tell me what row I'm on. So that is going to start at 0 and go to 35. And actually, I don't mean 35. I mean the upper boundary of my hotel array. I want that for both of these. Next. What's that? Thank you. Upper boundary of hotels. Thank you very much. I'll tab this in. Now, let's think about where we're putting the data. Now, it's a little bit interesting because our data doesn't just go straight down. So this one isn't here. So when I'm on row 0 in my array, writing to row 0, let me look at the arrays version of this. When I'm writing to row 0, I start writing at column 1. When I'm writing to row 1, I start writing at column 2. Row 2 gives me column 3. Row 3 gives me column 4. So every time we've made a for loop so far, we've always just, the range has been like just known range. But here, we're not going to start at 1. Where are we going to start? K plus 1. So when k is 0, we want this expression here to be 1. When k is 1, we want it to be 2, and so forth. And so now we're going to write to the kth row and the ith column. And instead of writing, reading from row 2, we'll read from row k plus 2. Whew. Nested loops are a little bit tricky. Let's just kind of follow this one through. So we come down here and we say, all right, we're going to start right here. So that makes k 0. And then we get here and we go, oh boy, starting another one. I is going to be what? 1. And then we run this through. K is 0, 1, the same thing that we ran the first time last time, 0, 1. We hit the next. That sends us up to here, and that makes I go up by 1. What's k? K is still 0. And so I is going to be 1 more than it was. I is going to be 2. And we run this. I is going to be 3. I is going to be 4. K is still 0. I is 5. I is 6. I is 7. 8, 9, 10, 35. We finish the loop. We come to the next. Next sends us back up here. And k now goes up to the next one, which is 1. And now we say I is going to start again. It's going to be 1 plus 1. I is going to start at 2 the second time through. And it will bing, 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 go across every column in that row. We'll get to next. Go back up. K will go to the next row down. Bing, 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 bing. We'll go across every column. And that should give us the first part of that array, at least the part where we have the numbers. So we'll run this. Hit a stop. Let's run this. I don't think it. Let's run this again. I think I was already running it. There we go. So now I should be able to look at dist 0, 3. I should be able to look at dist 2, 3. I should be able to look at dist 4, 3. Ooh, what happened? Why is that one 0? I expect 3, 3 to be 0 because that's distance from hotel 3 to distance to hotel 3. But hotel 4, 3, that distance is 0 because whenever the first index is larger than the second index, I'm down here in this part of the array that I haven't initialized yet. Well, here's the good news. When I write to row, let's see, when I write here to row 0, column 1, I got to write the same value to row 1, column 0. When I write to row 1, column 2, I have to write the same value to row 2, column 1. Do you see the pattern? Yeah, I just have to invert the indices. So the second value that I'm going to write, I'll just copy this line and put the I first and then the K. And so now if I run this, I should, whether I put the 4 first, whoa, is the difference between 4 and 2? Well, it really is 2. Yeah, those are close to each other. I guess they're probably both in the same town. So whether I look at 14.3 or 3.14, it should now be the same number. Okay, that's what I wanted to get done today. Got it in the nick of time. We've got our arrays initialized. We haven't really started solving the problem yet. We've just got the problem set up. And so next time we get together, we will solve the problem by creating the whole route. Questions? Thanks for coming. Class dismissed.
Yours is updating, right here is your running errors.
It is not updating.
Okay.
So I did a copy and paste there to kind of show you we've got to get those numbers across.